Okay, so recording in progress. We're now recording. And let me go ahead and get started. So let me hit share screen. Okay, so we're here. Today and tomorrow, 1.2. Tomorrow's quiz will be on 1.2. I'll give you the quiz. And quiz is really, in quotes, it's about as low pressure a quiz you can get. It really should be assignment. But in my grade book, it's a lot easier to just put QUIZ than ASSINGMENT. Okay. It's open book, open note, open discussion. You can look it up on the internet. You can talk to your friends. It isn't even due at 10 o'clock. You have until 11:59 p.m. to finish it, right? So who could ask for anything more, right? So even though it says quiz, sometimes it's scary. It's a quiz. It's really an assignment. So work it out in paper. Then get your cell phone, click, 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 take a picture on your cell phone. Or if you have a scanner, you can scan it and then email it to me by 11:59 p.m. Okay, good deal. So again, quiz is really in quotes. It's more like assignment. Okay, so I'll get going with 1.2. And the assignment is 1 to 71 odd, 75, and 77. I end up doing a lot of these problems in class, so that makes it less that you have to do. Okay. I will always show you key pages in the text. So if you say to yourself, I'm not going to get the book, I can't afford the book, I'll show you all the problems that you need, all key pages that you need, so you can survive just by doing it that way. Okay, so I did very little of it yesterday, and let's continue on for today. Okay. All right, so here we go. So last time, I think I only did some of these problems here involving interval notation. So we're going back and doing 1.2. For those of you that have the text, is on page 12 and doing these homework problems. Okay, you can always watch the video for what the problems are. I'll show it to you again. Okay. In case you're saying I'm going too fast, remember, you're not supposed to write all this down now. Watch the video. You can always pause, rewind, fast forward as much as you want. Okay. All right. Okay, so we were over here, I believe. Okay, so problem 15, x is greater than or equal to 3. Write it in interval notation. So interval notation, that means you're including 3. So bracket 3, greater than means infinity. Infinity and negative infinity always use parentheses. Okay, so I have a closed circle on 3, and it just shade over to the right. And by the way, if you ever wonder, how much work should I show? Always show the same kind of work that we did in class. That's always a good idea. However we did in class, you do the same thing. Okay, so again, I don't accept just a final answer without any work. I need to see all the in-between steps, like all this stuff or all this stuff or whatever, right? If you just give me an answer without any work, no credit. Okay. If you get the wrong answer, but you show me work, I'll give you a lot of credit. Okay? So in other words, it's possible for you to get more points if you got the wrong final answer, but your work was good, than if you got the correct final result, but what you did didn't make any sense or you didn't show me any work. Okay, so when in doubt, do as much as we did in class. That's for everything you turn into quizzes, homework, and exams. Okay. All right, we had some problems involving distance between 2 points. Okay, so on a number line, what's the distance between -3 and 5? That's pretty straightforward. It's just a bigger minus a smaller. All right. Again, these are problems right out of the homework. So 17, 18, 19, 20, find the distance between the points and the midpoint. So distance is just bigger minus smaller. So 5 minus a -3 is 8. How do I find the midpoint? Okay. Well, if it's easy, you can go intuitively. I suppose I say, what's the midpoint between 4 and 6? Well, 5. That's obvious, right? What's the midpoint between 10 and 20? 10 and 20, well, 15. What if the numbers weren't so nice, like 3.16 and 5.21? Okay, well, you would average the numbers, right? Like when I said 4 and 6, if you want to go by formula, I mean, you just intuitively know, oh yeah, 4 and 6, midpoint is 5. But if you need a formula, you could take the average, right? 4 and 6. What's 4 plus 6? 10 divided by 2, 5, right? And let's say 10 and 20, I said. What's the midpoint between 10 and 20? If you want to go by formula, what's 10 plus 20? 30 divided by 2, 15, right? So I average. You average the two numbers. So for 19, the midpoint, you just average it. So I add them up and divide by 2. So -3 plus 5 and divide that by 2. So 2 divided by 2, 1. So the midpoint between -3 and 5 is 1. And if you think of the number line, how far is it from 1 to 5? 4. And yeah, how far is it from 1 to -3 is also 4, right? If you stop and think about it. And you'll notice in my demonstrations, I show you at least one of each type of problem. And so each fundamental type of problem, I show you at least one. Okay, so let's say in this set, I show you at least one of these. I show you at least one of these and one of these and one of these, one of each basic type, right off the homework. So if you look at the rest of the homework and say, I don't know what we did, look at the one that we did in class and try to mimic the same idea, right? And then we'll do this stuff and blah, 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 blah. Okay. Okay, review of factoring. X squared plus 5x plus 6. Remember doing this in algebra, right? Some of you might recall FOIL, first, outer, inner, last. This was first, this was last, this was a combination of outer and inner. Okay. Now you pretty much should know whenever they give you problems like this, x squared is going to be x and x, right? X here, no question about it. Furthermore, I see a plus and a plus. I know plus plus is plus plus. Okay. And I see a 5 and a 6. So what two numbers have a sum of 5? Product of 6. 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. So final answer, x plus 2, x plus 3. And how do you check your answer for the back out? Right? X times x, x squared. X times 3, 3x. 2 times x, 2x. 3x plus 2x makes 5x, and then 2 times 3 is 6. And yes, if you put the 3 here and the 2 here, that's the same thing. That's full credit. Okay, factor x squared plus 4x minus 12. Well, once again, x squared, I know is x times x. So x here, x here. This minus tells me the signs are opposite. One's a plus, one's a minus. That means I want a difference of 4. So I have to say to myself, what two numbers have a product of 12 and a difference of 4? 6 and 2, right? 6 times 2 is 12. 6 minus 2 is 4. And let's see, I want to end up with a plus. That means plus should go with a bigger number. So x plus 6, x minus 2. And double check by foiling it out, right? X times x is x squared. Minus 2x plus 6x is a plus 4x and minus 12. And yes, it's the same thing if you put this in front. So if you go x minus 2, x plus 6, that's the same thing. Full credit. What's not the same is x minus 6 and x plus 2. If you FOIL that out, you don't get the same thing. We'll watch out for that. All right, okay, these are problems right off the homework. So everyone I'm doing is one less you have to do. Now, when it comes to submitting the homework, just copy what we did. And then for the other problems that I didn't do something similar. Okay, 27 and 29 talk about the intersection and the union of intervals. So I have to talk about what that means, union and intersection. All right, so they give me bracket -1, 3, 0, 4. So here's what I want you to do. I draw my number line. First above, I put bracket -1, 3. Get this into focus here. Come on. Go. Okay, bracket -1, 3 bracket. So closed circle here and here. -1, 3. Then open interval 0, 4. So 0, 4, open, open, shade that. Okay, now union. Union means taking, whoops. Yeah, union means everything here is in this final answer. Everything here is in the final answer. It's almost as if to say, if I were to shine a flashlight straight down, what would get covered? Everything here gets covered, and everything here gets covered. Okay, so -1 to 4. It's anything that got shaded at least once, so to speak. Okay, so everything, it's like, just go ahead and shade all of this, and then go ahead and shade all of this. So -1 to 4, not counting the 4, but I count at -1. So that's the union, bracket -1, 4. So it's a set of points that are either in here or here. Think of union as an or. It's either in this or this. Intersection means what do they have in common? It has to be in both sets. Okay, so I would throw this out. Okay. And can you see only the region from here to here are in both sets, right? It's in here and it's also in here. I don't count the 0. Everything here is included twice. And I include the 3, but nothing after the 3. This would be the intersection. It's in both of them. So if I say the intersection of, I don't know, 31st Avenue and West Hillsdale, right? It's got to be in both. So, 31st goes like this, West Hillsdale goes like this. Intersection means it's in both of them, right? So the intersection is, it's got to be here, and it's also got to be in here. So that's everything between 0 and 3, not counting the 0, but including the 3. Okay. We use U for union, upside down U for intersected. That's pretty easy because U starts with, union starts with U. So here's intersection. Okay, so the union is bracket -1 to 4. It's anything in here or here. Imagine shining a flashlight straight down. It's got to be in both of them. Intersection, so you must cover both of them. Okay, so covering both of them is parenthesis 0, 3, and bracket under 3. Okay, so that's my intersection.
So on the homework, you're expecting number lines for these answers, right?
Okay, let's see. That's what yes, you want these. And let's see, I'd like to request going over 77. Let's see if we have time for 77. Yeah, I may not get to it today, but maybe tomorrow. For this kind of problem, yes, she'll be, yes. Okay. All right, the next set of problems are inequalities. That's most of the rest of the problems. How to do stuff like less than, greater than, less than or equal to, and so forth. Okay. All right, so 35, -3x plus 4 is less than 5. Oops. This thing has a mind of its own sometimes when it comes to focusing. All right, so these linear inequalities, if there's no squared or not multiplied by anything, you pretty much work these out just like you did equalities. In other words, pretend it says equal, right? If there's an equal sign, what would you do? You say, oh yeah, subtract 4, divide by -3. Guess what happens here? Same thing, subtract 4, divide -3, and so on. There's just one extra tricky thing to watch out for when you multiply and divide by negative. Okay, so let's look at this. How do I get rid of the plus 4? -4, right? -3x is less than 1. By the way, you say to yourself, do I have to take notes? It's up to you. I mean, you might say, oh, I can't write all this down. You can watch the video later. Whoops. Why does it want to get off focus on its own sometimes? Sorry. So it's up to you if you want to take notes. Now, if we were meeting face to face, I know, we didn't have this, so you're furiously writing stuff down to make sure you got it all right. But since the video is recorded, if you just want to sit back and watch and just look at the video later, right? You can always look at the video and fast forward and rewind as much as you want. Okay, so it's up to you if you want to take notes. Okay, anyway, how do I get rid of -3? Divide -3. Okay. Now, here's something that's easy to forget. For inequalities, if you multiply or divide by a negative, do you recall what happens to this sign? The inequality symbol reverses. Remember that? When you multiply or divide by a negative, inequality reverses. So when I divide by -3, it isn't going to be less than anymore. It's greater than. X is greater than -1/3. So there's my solution set. Okay, how do I write that as an interval? We're going greater than, so parenthesis, -1/3, infinity, and then parenthesis. Remember, infinity is always on the right side. Negative infinity is always on the left. And both negative infinity and positive infinity always use parentheses. They never use brackets. Okay, so -1/3. So here's 0, here's -1. So roughly -1/3 is like that. And greater than means I shade on this side. All right, so there we go. 39 looks like this. In case you're wondering, you say, hey, he's doing problems right off the homework. That's right. Which means, even though you're responsible for these problems, I end up doing a great chunk of them in class anyway. So you know where I put in the syllabus, you have to do at least 70% of the homework for me to accept your exam, right? I put that here somewhere. Right? You must have at least 70% of the homework complete. In class, I do what? 25%, 30%, maybe 50%. So it's not that hard to do, in other words. Okay, here is a double inequality. That means they give me a sign here and a sign here. 39. So basically, you do the same thing to all three of them. So look at the thing in the middle. How do I isolate the x? Well, I'll get rid of that and get rid of that. So how do I get rid of the -3? No, add 3. And you know how we usually say add 3 to both sides, quote unquote? Well, here there's 3 sides. So you do the same thing to all 3 of them. So +3, +3, +3. So you do the same thing to all 3 of them. So this cancels out, 3x in the middle. 6 + 3 is 9. -1 + 3 is 2. Okay, I need to isolate the x. How do I get rid of the 3? Divide by 3, all 3 of them. Okay, now, this time I'm dividing by a positive. Over here, I divided by negative, right? If I divide by a positive, do I have to change the inequality symbol? No, I don't. So it stays less than, less than. Okay, so the middle is just going to be 1x, which is x. 2 divided by 3 is 2/3. 9 divided by 3 is 3. Okay, so interval notation is 2/3, 3 in parentheses. So here's my number line. 2/3 is like there, right? Here's 3. Open circles. Don't count 2/3. Don't count 3. Shade everything in between. Right? And now much harder are these kind of inequalities. They're not linear. Okay, they've got squares in them and cubes and all that. There's a certain process for doing these. Okay, so these are a little bit tougher, and there's even some fractions. So I'll show you how to do something like that and something like that. Okay, 43. X squared minus 4x plus 3 is less than or equal to 0. All right, you cannot work this one out the same as these. This is a quadratic right here, which means there's an x squared. So it has to be done differently. So first thing we want to do is factor this. Can you think of how to factor that? It's going to be x and x. What two numbers have a product of 3 and a sum of 4? In other words, when you multiply them, you get 3. When you add them, you get 4. Well, 3 and 1, right? And a minus and a plus means minus minus. So there we go. X minus 1, x minus 3, less than or equal to 0. What's going to happen now is you have two boundary numbers. You just say to yourself, what makes this 0? What makes this 0? What number would make this thing 0? 1. What number will make this 0? 3. So I put them on a number line. 1 and 3. Okay, I'm trying not to show you the finished product, but I put a 1 and a 3. Now it says less than or equal to 0. What happens if I do plug in 1? Here and here. 1 minus 1, 0, times whatever that is, it's still 0. It'll be 0 is less than or equal to 0. Is that a true statement? Yes. Shade in 1. Likewise, I'm going to shade in 3, because if I plug in 3 here and a 3 here, and then I notice, hey, 3 minus 3 is 0. 0 times whatever that is also 0. It again says 0 is less than or equal to 0. True. So close circle, close circle. Now, don't worry yet about how I got that. I'm going to do that in a moment. Let me just say quickly, if I didn't have that line underneath it, if it just said less than 0, can you guess what that means about these two circles? If it just said less than.
They'd be open.
Okay? In other words, it would just be like so. They would both be open. Because your inequality would then say 0 is less than 0, which is false. And same thing if you plug in 3, it would say 0 is less than 0. So correct, these would both be open. Okay, now the finished product already looks like this, but right now we don't know that. At this stage of the game, I have 3 regions now. I call it region 1, 2, and 3. And I either shade in the region or I don't shade in the region. So region 1, 2, and 3 in Roman numerals. Okay. Pretend this isn't shaded in yet. Okay, so what I do now is I pick a number here, pick a number here, pick a number here, pick a number in each region. So region 1, I said 0. Region 2 is in the middle. What's a number between 1 and 3? 2. And what's a number in region 3? That means bigger than 3. 4. But you would also pick 5 or 6 or 80 or 1,000,000. But, 4 is nice. Okay, what you do now is plug in each of these to the inequality. And you're not really concerned about the exact value. You're only concerned about the sign. So I make what's called a Sine chart. I only care about the sign, S-I-G-N. Right, so I'm going to plug in 0. 0 minus 1 is -1, but the only thing I care about is that it's a negative. I'm not interested in the exact value. I just want the sign. Plug in 0 here. 0 minus 3, -3. The main thing is that it's a negative. So I have a negative quantity times another negative. What is a negative times a negative? Positive. So the left-hand side, all this junk over here is a negative. It's a positive. So a positive less than or equal to 0 is a positive less than or equal to 0. No, that's false. Which means I do not shade in region 1. False means don't shade it in. True means shade it in. So one more time, plug in 0. 0 minus 1, negative. 0 minus 3, negative. Negative times a negative, positive. Positive less than or equal to 0. No, that's false. So don't shade in region 1. Evidently region 2 is going to be true because I must have shaded it in. So now I plug in 2. Okay, so let's see. 2 minus 1, 1, positive. I don't care about the exact value, just the sign. 2 minus 3, -1, negative. So I have a positive times a negative, negative. Negative less than or equal to 0. Negative less than or equal to 0. Yes, that's true. So I shade in region 2. Same thing for region 3. Plug in 4. 4 minus 1, positive. 4 minus 3, positive. Positive times a positive, positive. Positive less than or equal to 0, that's false. Do not shade in region 3. So my solution set is only the stuff between 1 and 3, including 1 and including 3. So here's a solution set, bracket 1, 3, bracket. Bracket means I count both the endpoints. Okay, so that's the essence of how to do a problem like this. I'll show you more. There's some much harder ones. 51. So what do I do if there's a fraction? A lot of it's the same, but a lot of it isn't the same. X plus 3 over x minus 1 is greater than or equal to 0. X plus 3 over x minus 1 greater than or equal to 0. Okay. On my number line, I put down whatever makes the top 0, whatever makes the bottom 0. So what number would make the numerator 0? X plus 3. What number would make that a 0? It would be negative 3. Right? So negative 3 goes in. What number makes the bottom 0? 1. 1. So on my number line, I put negative 3 and a 1. Okay. Now it looks like this time one of them shaded in and one of them isn't. Now why is that? Okay, so plug in negative 3. Negative 3 plus 3 is 0. And I don't really care what that is as long as it's not 0. This is 0 divided by something, right? So wait a minute. 0 divided by anything besides 0 is 0. It says 0 is greater than or equal to 0. 0 is greater than or equal to 0. That's true. Color it in. Now, how about if I plug in 1? Plug in 1 here and here. But what happens when you plug in 1 here? 1 minus 1 is 0. I'm dividing by 0. And we already know that's a mathematical no-no. I'm not allowed to do that. So automatically, that's open circle. Okay. So here's a case where one of them's open and the other's closed. And again, pretend you don't know the final product like this. So this stage of the game, I have negative 3 closed because negative 3 works. Negative 3 to plus 3 is 0. 0 divided by is 0. 0 is greater than or equal to 0. But 1 doesn't work because if I plug in 1, I'm dividing by 0. And now again, I pick a number in region 1, 2, and 3. So what's something over here? I pick negative 4. Something in the middle, 0. I always like plugging in 0 because the math is usually easier for 0. And what's something over here? How about 2? Okay, this time, because it's a fraction, I do like that. That's a fraction bar, fraction bar, fraction bar. So ignore the red for the time being. Fraction bar, fraction bar, fraction bar. Now I plug in. Negative 4. Negative 4 plus 3, negative 1. I only care that it's negative. Negative 4 minus 1. Negative 5, negative. Negative divided by negative, positive. Positive greater than or equal to 0. That's true. Shade in region 1. Zero. 0 plus 3, 3, positive. 0 minus 1, negative 1, negative. So that means it's a positive divided by a negative, which is negative. Negative greater than or equal to 0. No, that's false. So don't shade in region 2. Finally, region 3. 2 plus 3, positive. 2 minus 1, positive. Positive divided by positive, positive. Positive greater than or equal to 0, that's true. Shade in region 3. So any true region, shade it in. False regions, don't shade it in. And yes, you have to check the boundary numbers separately, as you can see right over here. All right, so how do I write this? I'm going all the way to the left, so negative infinity, comma, -3. I'm including -3, so a bracket. Okay, and then you join them with a U. U stands for union. When you have more than one set like this, join it with a U for union. And then I'm not counting 1, so parenthesis 1, comma, all the way to the right means infinity. And remember, negative infinity and positive infinity always use parentheses. So that's my solution set for this one. Okay. Okay, now 47, it's a little bit longer. Now, I'm intentionally going out of order because I want to do, this was actually a little bit easier, but now there's going to be 3 things that you have to factor out. So problem number, which one did I say, 47? How do I do that? So first we have to factorize. X cubed minus 3x squared plus 2x is greater than or equal to 0. Okay, factor. I can take out an x. X squared minus 3x plus 2. Factor further. Minus and a plus means minus minus 1 and 2. So x minus 1, x minus 2. Greater than or equal to 0. Looks like I'm going to have 3 boundary numbers. So we say what number makes this 0, this 0, this 0. Well, this one's easy. What makes this 0, 0? What makes this 0, 1? What makes this 0, 2? So my number line, I plunk down 0, 1, and 2. Those are my boundary numbers that I lay down. Okay, so 0, 1, and 2. Ignore the red temporarily. That's the finished product. They're all closed circles. Now, why are they all closed circles? 0, 1, and 2, because they all satisfy the inequality. If I plug in 0 here, here, and here, well, 0 times any of that is automatically 0. It'll say 0 is greater than or equal to 0. True. Likewise, if I plug in 1 in all of them, 1 here, 1 here, 1 here, and then I look at, oh, 1 minus 1 is 0. So 0 times these 2 guys is also 0. 0 greater than or equal to 0. True. Plug in 2 here, here, and here. And then I say, oh, 2 minus 2 is 0. So 0 times all that is 0. So they're all true. Okay. And this time it looks like I have 4 regions. Stuff to the left of 0. Stuff between 0 and 1. Stuff between 1 and 2. And stuff greater than 2. So I pick a number in each region. So smaller than 0, -1. Here, well, half, 0.5. Region 2. Region 3, well, 1.5. Region 4, 3. Plug in. Again, I only want the sign. I don't need the exact value. -1 is negative. -1 minus 1, negative. -1 minus 2, negative. 3 negatives. Negative times a negative times a negative, negative. Is a negative greater than or equal to 0? No, that's false. Do not shade in region 1. Do the same thing for all of them. 0.5. You can really see here, you don't want the exact value, right? It's going to be very messy, but I just want the sign. 0.5 positive. 0.5 minus 1, negative. 0.5 minus 2, negative. So I'm going to have a positive times a negative times a negative, two negatives, positive. Positive greater than or equal to 0. That's true. Shade in region 2. Okay, region 3, 1.5. 1.5. Whoops. Just focused here. Come on. There we go. Okay, 1.5, positive. 1.5 minus 1, positive. 1.5 minus 2 is a negative. Positive times negative, negative. Negative greater than or equal to 0, that's false. Don't shade in region 3. And finally, region 4. They're all positive. Let's see, 3 is positive. 3 minus 1, positive. 3 minus 2, positive. Multiply a bunch of positives, positive. Positive greater than or equal to 0, that's true. Shade in region 4. Right, so what's my solution set? Here, so that's bracket 0, 1 bracket, union bracket 2 to infinity, parentheses. Right. Okay, I'm just going to go ahead and tell you ahead of time, your quiz tomorrow that I'm going to be giving you is very similar to some of this stuff. Very much like it. Okay, let's see, how much time do I have? I'll get you going with 55. This is much longer. It's a fraction. But all this stuff, blah, 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 greater than 0. Okay. So let's see, I'm going to have 1, 2, 3, 4 boundary numbers. My boundary numbers are whatever makes this, 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 or this 0. Okay. 1 minus x. What makes that 0? 1. X plus 2. What number makes that 0? Negative 2. What makes x 0? Well, 0. X plus 1. What makes that 0? Negative 1. So I have 4 boundary numbers. Negative 2, negative 1, 0, and 1. Okay. They're all open because none of them will be true. Let's just say if I plug in 0, you're dividing by 0. If I plug in negative 1, you're dividing by 0. If I plug in 1, 1 minus 1 is 0. The left-hand side would be 0. It would say 0 is greater than 0, but that's false. Okay. So these are all going to be open. Right, so this time there's going to be 5 regions. I've got 4 boundary numbers, negative 2, negative 1, 0, and 1. I have 1, 2, 3, 4, 5 boundary numbers. Okay. So pick something here, 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 and here. So negative 3, negative 1.5, negative 0.5, positive 0.5, and 2. Again, you're plugging into this expression, and I only want the sign. Okay, negative 3. 1 minus a negative 3. Positive. Negative 3 plus 2. Negative. Negative 3 is negative. Negative 3 plus 1. Negative. 3 negatives. When you multiply and divide, 3 negatives, end up with a negative. Negative greater than 0? No, that's false. Do not shade in region 1. Do the same thing for all the others. negative 1.5. 1 minus a negative 1.5. That's a double negative. That's a positive. Negative 1.5 plus 2. Positive. Negative 1.5 is negative. Negative 1.5 plus 1 is negative. So I'm multiplying and dividing, and I have two negatives. Positive. Positive greater than 0, that's true. Shade in region 2. Keep going. Region 3, negative 0.5. 1 minus a negative 0.5, positive. Negative 0.5 plus 2, positive. Negative 0.5 is negative. You can see how this is be quite a bear if I had to find the exact value, right? I don't need the exact value, I just want the sign. Negative 0.5 plus 1, positive. So it looks like I have 3 positives and 1 negative multiplying and dividing. That's going to come out negative. Negative greater than 0, that's false. Do not shade in region 3. Okay, region 4, 0.5. Looks like they're all positive. 1 minus 0.5 is positive. Well, these are clearly positive, right? Positive plus positive, positive 0.5. So 4 positives, positive. Positive greater than 0, true. Shade in region 4. Finally, region 5, okay. If I plug in 2, here, here, and here, they're clearly positive, right? Whoops, why does the machine want to go out of focus on me once in a while? There we go. Okay, plug in 2, positive, 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 right? But what about this? 1 minus 2, that's a negative. Negative, positive, positive, positive. So I have 1 negative. When you multiply and divide, negative. Negative greater than 0, false. So my only true regions are right here. So my final answer is, they're all parentheses, negative 2, negative 1, parentheses, union 0, 1. Okay, and I think that's all I was going to do for today. So I think we're okay schedule-wise. I have tomorrow to do the rest of 1.2. So sorry I didn't get to the question 77.
Okay.
I might be able to get to 77 tomorrow. But tomorrow's quiz that I'll give you will be stuff sort of like this and like this, where you have to take a region and figure out the true regions and false regions and go from there. Okay. And so I'll try to do the rest of the problems from 1.2 tomorrow, and I'll give you the quiz tomorrow according to schedule. That's where we are. Okay. So we have maybe 5 minutes left. Anybody else has to ask a question, please?
How long generally are the quizzes and exams?
Okay,
Like
exams you have to finish in one. Exams you have to finish in an hour. Okay, quizzes I would typically give maybe 2 or 3 questions on a quiz, but you have more than half a day to do quizzes. So,
cool. Yeah. No. Okay. Cool. Thank you.
Welcome. All right. Anybody else with a question, please? Otherwise, we're done for the day. Let me check the chat quickly. Okay, I hear nothing and see nothing, so we'll call it a day. All right, folks, have a good day, and we'll see everybody tomorrow. All right. Okay, bye, everybody.
Thank you, Professor.
Thank you. Have a good day. Will the denominator always be an open circle? Yes, if you have an expression in the denominator.